Hello, I am doing this session on problem solving. You're definitely going to want to write down my problem solving steps. They're going to help you with your homeworks, and I'm also going to go over some velocity, distance, and time problems. I have a worksheet that would be similar to your worksheet for homework. But the most important thing is to stop and start this recording and make sure you're writing down these problem solving steps. It's very important that you actually do things and not just watch my videos. I would also suggest that while you're watching my videos, you stop the videos and you take notes. You should be taking notes on the equations and any of the examples that I'm taking. Why do I ask you to want to take notes? Because learning is, when you're taking notes, you're listening and you're writing down, so that's a two-step process in your brain, and you're going to be able to remember it better if you do things like that. So back to my problem solving steps. You definitely want to write these down. You're going to be able to, even if you get an answer wrong on one of my exams, if you show all of the problem solving steps and show all of your work, I'm going to give you more than half credit. So you will definitely pass the exam. So you definitely want to be able to do these things for me. So problem solving steps. First thing is you always want to draw a picture. Now, it might seem pretty silly to do that for this type of problems, but very quickly we're going to get into problems where you're definitely going to want to know what's going on. So drawing a picture is definitely a must. The second thing you want to do is, in the word problem, you want to list your knowns. That's basically identifying the numbers and the units to what they associate with. So if there's 100 kilometers, we'll know that's a meter, so that means that's distance. So that's definitely something you want to look at. So you want to draw a picture, you want to list all the knowns, all the values that you have, and attach them to your variables. Then, what are you trying to find? Now, for some of the problems for the velocity, it'll say how long, that means they're looking for time, how far, that means they're looking for distance, or how fast, that means they're looking for velocity. Okay, so you definitely want to make sure you know which variable you're looking for. Then you want to look at the knowns and make sure you're putting them into their units or their scientific notation, or if you need conversions. A lot of times they'll give you something in minutes or hours and you need everything in seconds, so you've got to convert. Sometimes you'll have stuff in kilometers, which means you have to put the scientific notation in there because you need it to be putting in the calculator in meters. Okay? So that's definitely a thing. Now, you also, so you want to know what you're trying to find. You have your knowns, so you got to look at the equations. Now, right now we got one equation, so it's really finding the equation and rearranging the equation. But as soon as we introduce acceleration, it can get confusing. So you need to list all your equations and then try to figure out which equation you're going to use, and then you need to rearrange the equation so that you're solving for the right variable. Then, the easy part. You're going to put in the knowns in the equation, calculate it, and then I always like you to list it to 3 digits. That means 3 after the decimal. And you always want to check your units in your answer to make sure that you solve for the right thing. Okay, I hope this helps. I'm going to be following this for my set of problems that I want to do. So you definitely need your calculator for these. Oh, you barely can see them. Hold on, let me see how I can make this. I'm going to try to bring them up. Okay, so these are just practice problems. I actually found them on the web, but so don't look for them in your book. So here's one. So they gave us some conversions and they gave us the simple equation. Well, I want to write our equation that I've been showing you, which is velocity is equal to distance over time. So there's my equation that you need to use. The other one that I find is useful is 1 hour is equal to 3,600 seconds. I don't think they put that in there. Okay, so the first problem. A school bus travels 240 kilometers in 6 hours. What is its average speed for the trip? And they're being nice right now because they're saying we can keep it in kilometers per hour. So I got a school bus. Okay, and it's traveling, so it's going, I'm just going to say the whole thing is 240 kilometers, and it took them 6 hours. So now I want to list my knowns. I always underline my values. And then it's what is, and we're looking for speed. So this is a kilometer, so that's my distance, 240 kilometers. 6 hours, so that's a time, 6 hours. And I'm looking for my velocity, speed. So now I have my knowns, and I listed my own known. And now if I want to look at this, this is in hours and this is in kilometers. So right now, because they said I could keep it, I don't have any conversions. And so then I'm looking for V. So V is distance over time. So you just fill in 240 kilometers divided by 6 hours. So this is real simple. So I got 240 divided by 6. So it's 4. Oops, sorry. 240 divided by 6. So that is 40. Sorry, I was not seeing that one. 40 kilometers per hour. There we go, 40. That was in my scientific notation. The next problem. It says a spider travels, hopefully you can see that, a spider travels across a driveway 3.6 meters wide. So I got my Spidey, and I'm going across the driveway 3.6 meters. And he's moving at a speed of 14 centimeters per second. How long will it take to cross the driveway? So, first of all, I'm going to underline everything here. I drew my picture. So, meters, that means a D. D is 3.6 meters. This says speed, so that's a V. V is 14 centimeters per second. We'll get to that in a minute. And then how long, that's time. Okay. So the first thing I want to do is I see a centimeter here. So I would want to rewrite this before, because centi is times 10 to the minus 2. And then I'd rather put that in the calculator. So then the time, if I look up here, it's going to be distance over velocity. So T is D over V. So I got 3.6 meters, and I'm going to divide by 14 times 10 to the minus 2 meters per second. That means the meters cancel each other out, and I'm going to be left with a second. So I got 3.6 divided by 14 EE minus 2, and I get 25.714 seconds. Everybody with me? Okay. Next problem. A caterpillar. Oh, I think you can see my drawings. There we go. A caterpillar travels across the length of a 2-meter porch in 6.5 minutes. What is the average velocity? So, I got my little caterpillar. with all its legs. And it goes across a big porch that is 2 meters long. And his time is 6.5 minutes. He's pretty, maybe he is fast. I don't know how fast caterpillars can go. And I'm looking for my velocity, question mark. So that means my distance is 2 meters. My time is 6.5 minutes. Well, we want the time to be in seconds because we need this in meters per seconds. So if you look, 1 minute is 60 seconds. I think everyone kind of knows that. So that means I'm gonna divide by. I want 1 minute to get that out, and I'm gonna multiply by the 60 seconds. So I want to put my unit in the right spot. Oops, sorry. So I'm going to be taking my 6.5 minutes times my 60 seconds. Wait, that looks too big. 6.5 times 60. Yeah. 390 seconds. I thought I did something wrong. And now I'm looking for velocity. So velocity is distance over time. My distance is in meters, so I can keep it that way. But now my time is 390 seconds. So I bring this back. And I take 2 and I divide by 390. And I'm going to put that in scientific notation. So my answer is 5.128 times 10 to the minus 3 meters per second. Okay. I know I make this look easy, but see how I'm drawing my pictures, I'm listing my knowns, what I'm trying to find, I'm checking to make sure that they're all in the correct units, and then I literally just look at, I look at this all the time to be able to rearrange my problems. Okay, we got 2 more to go. So this says, I'm going to make sure I have enough space for you. A hiker's at the bottom of a canyon facing the canyon wall closest to her. So here's my hiker. She's 280.5 meters from the wall. 280.5 meters from this wall. The sound of her voice, so now we're talking about the voice, so V of sound is 340 meters per second. How long is time? We're looking for time. After she shouts, will she hear her echo? So I will tell you there's a little bit of a trick here, but we're looking for time. The problem is her voice is going this way, right? That's how long it takes for her voice to hit the wall. Then sound has to go back to reach her ear. So we're going to find the time for it to go to the wall, and then we're going to multiply it because it has to, sorry about this. Sorry, you didn't see my little wall over here. Apologize. So anyways, I'll say that again. So her voice is traveling to the wall. We have the distance and the speed. So we can find the time her voice took to get to the wall. Okay? But they're looking to see when she's going to hear the echo. So that means the sound has to bounce off the wall and come back to her ear for her to hear it. Okay? So that means we're going to find the time it takes to hit the wall, and then we're going to multiply it twice because it's basically goes back. So now let's list our knowns. So distance is 280.5 meters. and the speed of sound is 340 meters per second. So we're going